Hello, I am Yeap Jian Feng. Today, I am analyzing a rigid body undergoing pure rotation, the car hood of a proton saga during closure. Point O represents our fixed hinge pivot, the measured parameter of a mass of 13 kilo, a total length of 1.0 meter, and the center of mass G located at the 0.5 meter, which is midpoint. Evaluate this system at a release angle of 60 degrees relative to the horizontal, moving a clockwise angular velocity of 1.5 radian second. To model the kinetics, I construct a free body diagram and a kinetic diagram. The free body diagram contains our external force, unknown hinge reaction OX and OY. The downward weight mg at G, a 50 Newton hand force applied 0.95 meter from the hinge, and a 100 Newton resistive gas strut force applied at 0.4 meters. The kinetic diagram displays our inertial response, tangential acceleration, normal acceleration, and rotational inertia. Approximating the hood as a uniform thin rectangular plate gives a central moment of inertia Ig of 1.08 kilometer per kilometer square. Applying the parallel axis theorem shift this value to the pivot, give an IO of 4.33 kilometer square. This dynamic setup solve our angular acceleration as 8.23 radian per second square, which is in clockwise. Evaluating our model highlight critical limitation. First, assuming a uniform plate neglects the non-uniform mass of the steel inner ribs and latch mechanism, which shift the actual center of mass closer to the hinge. Second, omitting the mechanical hinge, pin friction, and aerodynamic drag means our calculated acceleration is higher than in reality. However, interpreting this figure provided with the structure insights, moving 1.5 radian per second create a normal acceleration component that includes a high set shear force on the hinge. For safe design, this dynamic load must be verified against the ultimate shear capacity of standard, which so can have a safety factor greater than 2.0 in the M8 grade 8.8 automatic box. Additionally, the high angular acceleration causes substantial kinetic energy accumulation right before the latch hit. This energy must be fully absorbed by the rubber stopper and latch bracket. Otherwise, excessive slamming force will be cause structural fatigue and metal deformation over time. In conclusion, because this model omit friction and air damping, our solution represent must be absolute worst case theoretical maximum. Thank you.